Welcome to Brain Vision.
So for this question, we start off with a block of mass being compressed against a spring until a distance of x. Right? So this is the amount of compression. And we are given that it then moves off along a frictionless surface and its velocity reaches 12 meters per second. So using this as the kinetic energy, we can find half mv squared must be equals to the elastic potential energy at start, which is half kx squared. So you can find x quite easily, just taking mv squared divided by k and take the square root. So the mass of this block is 0.5 kg. The velocity is 12 meters per second, and the spring constant is given as 450 newtons per meter. So for this, we should get the extension x to be about 0.4 meters. Now for part B, we actually want to find if the block were to reach the top of the track, what is the speed. So along the track, it actually experiences friction, right? We are given that this friction amount is actually 7 newtons. 7 newtons of friction. So there will be some work done by friction, and at the same time there will be some energy lost due to the gravity, right? So gravitational potential energy will be converted into kinetic energy will be converted into gravitational potential energy, right? So the total energy lost will be first the gravitational potential energy, where height is 2r, right? And also due to friction, which is given as F times the distance traveled, which is pi times r, right? Half of the full circumference of the circle. So it's 2 pi r divided by 2, which is as pi r. And this will, like putting all the values in, radius is given as 1 meter. And we should get about 31.8 joules. Now compare it with the total initial energy. Right, we can get what is the final kinetic energy by taking the initial kinetic energy of half mv squared, 12 meters per second square, minus away 31.8 joules, which is the energy that's lost. We should get about 4.2 joules, equating this to half mv prime square, where v prime is the final velocity, right? V prime just 2 times the kinetic energy divided by its mass. Then we take the square root. We should get about 4.09 or 4.1 meters per second. Now, does the block actually fall off or stay at the track? Well, to look at that, we need to understand the centripetal acceleration. Right, so mv squared over r, this is the centripetal acceleration that is required to keep it on the track, or centripetal force actually. Centripetal acceleration is just v squared over r. Given our velocity, our final velocity of 4.1 divided by the radius of 1, this is about 16.8 meters per second squared. So this is the amount of acceleration that is required to keep it in circular motion. Now remember that this is actually greater than our gravitational potential, gravitational acceleration of 9.81, which means that gravity alone is not enough to keep it in centripetal acceleration even at the top of the track. So at the top of the track, if it's just gravity, it will not be in circular motion. So what happens is that it needs the track to provide some of the normal force as the centripetal force, right, to keep it in circular motion. And this means that because there's a normal force, it means that our block is actually in contact with the track, and therefore it means that the block will stay on the track.